Okay, let's dive right in. Have you ever wondered what it really takes to land a top engineering job at a company like Cisco? Well, we got our hands on a real technical assessment they use. So today, we're going to take a tour inside an engineer's mind by breaking down the very test they have to pass. Just take a look at this. It's a question about the maximum operating frequency of a digital circuit. You see stuff like propagation delays, that's just how long a signal takes to travel, and setup times, how long a signal needs to be stable. It looks pretty intense, right? But here's the thing. Our goal today isn't to just find the answer, it's to figure out what a question like this is really asking, and what that tells us about the skills that matter most in tech right now. So, I want you to think of this as stepping right into the shoes of a candidate. They're not just answering a few questions. Nope. They are running a mental gauntlet. It's a whole series of challenges designed to push every single part of their technical brain to the limit. And all of it is against the clock. What you're about to see is that the sheer variety of these questions is completely intentional. One minute, you're wrestling with an abstract logic puzzle. The next, you're deep in analog electronics. And then, boom, you're writing code. This isn't just a pop quiz, it's a full-on simulation of the chaotic, jump-around, multifaceted nature of a real engineering job. So let's start where the test starts. Before you get into any of the heavy technical stuff, it kicks off with problems that, honestly, anyone could understand, but not everyone can solve, especially under pressure. This first part is all about testing raw, unfiltered analytical skill. Does that sound familiar? Of course it does. It's the classic Monty Hall problem. It's famous because it's a perfect test of how our gut feelings can be totally wrong when it comes to probability. Just for a second, what does your intuition tell you to do? Stick or switch? And there it is, right in the middle of a Cisco engineering test. Just having it here tells you something really important. They're not just looking for circuit builders. They want people who can reason logically about systems and odds. And by the way, the correct answer is to always switch. It literally doubles your chances of winning that car, taking you from a 1 in 3 chance to a 2 in 3 chance. And it doesn't stop there. On the left, you've got a puzzle about seating people at a table. On the right, a classic logic problem about figuring out what's in 3 mislabeled bags of fruit. Now, on the surface, these questions have nothing to do with technology. But underneath, they have everything to do with the core skill of systematic, logical thinking. All right, that was the warm-up. Now the test dives headfirst into the technical deep end. This is where that specialized knowledge in electrical and computer engineering becomes absolutely mission critical. You either know it or you don't. Okay, before we jump into these next few, here's a real quick primer. A logic gate is basically the simplest building block of a computer. You can think of it like a tiny decision maker that takes in some ones and zeros, follows a very simple rule, and spits out a single 1 or 0. The test starts you off with this. It's a circuit diagram made of transistors. The question is simple. What logical function does it perform? This is a fundamental check. Can you read a schematic and spot a basic pattern? The answer here is an XNOR gate, which is a fancy way of saying it outputs a 1 only if its 2 inputs are exactly the same. And right when you're getting settled in, the complexity just skyrockets. This is not simple digital logic anymore. This is an operational amplifier, or op-amp circuit. Is it an integrator, a rectifier? All of a sudden, you need to pull from a totally different area of expertise, analog electronics, to have any hope of figuring this out. And the test keeps you in that analog world. What you're looking at here is a parallel RLC circuit. RLC just stands for resistor, inductor, and capacitor. This is the kind of circuit you'd find inside a radio tuner or an audio filter. The question's about its power factor, which is a straight-up test of whether you can apply physics principles to a real electronic component. But look, in today's world, just knowing hardware isn't enough. A great engineer has to be bilingual. They need to be fluent in the language of circuits and the language of software. So the test pivots hard to check the other half of an engineer's brain. And here we go, a little snippet of Python code. The question is, what will it output? Now, notice how that max function has the word true in it. In Python, true is treated like the number 1. This isn't some trick. It's a direct test of whether you know the specific rules of the language and can follow the logic. The correct output, by the way, is 10. And here's another one. It's just a single line of Python, but it is packed with complexity. You've got multiplication and 2 exponents. Do you know the exact order of operations? A tiny slip up here and you get a completely different answer. Python's rules say the rightmost exponent gets evaluated first, which means the correct answer is 64. This is all about precision.
So let's just pause for a second and appreciate what's going on. In the span of just a few questions, a candidate has had to be a logician, then a physicist, then a circuit analyst, and now a computer programmer. The test is demanding just immense mental agility.
So this brings us to the most important question. Let's zoom out from the individual problems for a minute. When you look at this entire test as a single thing, what is it that a company like Cisco is really trying to measure? I think this quote just nails it. It's not enough to be a specialist in one thing. A successful candidate has to be a true polymath under extreme pressure, able to pull exactly the right piece of knowledge from this huge mental library and apply it to a new problem instantly. So here's the bottom line. This test isn't just about what you know. It's about these much deeper skills. It's measuring your raw analytical reasoning with those logic puzzles. It's testing your grasp of first principles from physics. It wants to see algorithmic thinking in your code. And woven through all of it is your ability to solve problems under pressure, with an insane attention to detail and just sheer mental endurance. You see, ultimately, the goal isn't to hire a walking textbook who has 1,000 formulas memorized. The goal is to find someone with a certain kind of mind, someone who knows how to see a brand new problem, break it down into its basic parts, and build a solution from scratch. They're hiring a way of thinking. Which leaves us with one final and kind of provocative question. This whole thing is a simulation designed to find the best people. But does a high-pressure, incredibly broad test like this really find the most creative and effective engineer? Or does it just find the person who is the best at taking tests? That's something to think about.